So we are now going to have Peter Cox and Alexander Voevoda, sorry. And Peter from Labs. So Peter Cox brings decades of operational cybersecurity experience to CHERI, founder of Labs and a pioneer of certified firewalls. He's now applying CHERI to real-time communications and edge systems for long-term assurance. And Alexander is a senior system engineer focused on turning high-assurance ideas into production systems. With over 30 years of experience in low-level C systems on Linux, he leads the implementation of Unicus Edge on Morello CHERI at Labs, bringing capability-based memory safety and post quantum cryptography into real-world streaming and IoT deployments. So welcome to both of you. And
thank you. Okay, well, good morning, everyone. My name is Peter Cox. I'll be joined by my colleague, Alexander Voevoda. And really today, we want to look at how we've taken a existing application which is widely deployed, and port that into CHERI BSD. We work in the real-time security area. So really in this session, I want to talk about the company, our application, and then move on to why we chose Morello CHERI. Why we chose Morello CHERI and the gains we experienced in that application from that exercise. Okay, so we are, as I said, a UK-based cybersecurity R&D company. Our technology is deployed in multiple government, defense, and commercial networks, and we're working with major European telcos. That includes the likes of BT, and KPN particularly. We're also working with system integrators in Europe, such as Atos. Our technology covers any real-time communication service on an IP network. That's everything from an IP phone service. So I'm sure you know the world's global phone network is moving from legacy technology to IP fairly quickly. We also go into things like streaming video. More recently, we've done work on cloud extended reality and some work on Internet of Things. The common thread here is that those applications have very tight requirements for delivering data very quickly and in real time with very limited delay and jitter, all on IP networks. What happens when we move that to a different platform? There's quite a range of applications there, but they all share a number of things. They all share a relatively small number of well-defined protocols. These applications are really split into two phases: signaling, setting the call up in the first place, the session up in the first place, and media, transmitting the media sessions. We use protocols like SIP and RTSP for session setup, RTP for media, and STP for setting the media streams up. All of these things we have to work in the platforms that we are deploying. For various reasons, and particularly because in many cases we are working with quite limited end-user devices, such as police body cameras, surveillance cameras, and so on, we have adopted a core edge architecture, where the bulk of our technology runs in the core, often in a public or private cloud. And then we have edge devices, which historically we've used things like Raspberry Pis for prototyping and development. Those edge devices then communicate with the core to provide a secure channel. Secure means authenticated, validated, encrypted with, of course, PQC encryption, because we're dealing with some very sensitive data, provisioning and data management. The edge device then will handle one or multiple rather smaller devices with very limited capability themselves. We've had edge devices running on Linux, BSD Unix, iOS, and Android. So why move to Morello CHERI? Well, we had two primary reasons. We work in very critical areas. We have to provide robust security software, well-tested and well-designed. Porting to CHERI BSD gives us additional assurance on the security of our design and the implementation of our software. It also gives us the ability to assess CHERI as a suitable deployment platform for areas of high security requirements. We're working in defense, where the data that we transfer really is critical, has to be protected, and the systems have to be robust and strong. what benefit can we get from using CHERI in that environment. For the exercise, we chose to port Unicus, which is our core product, running SVS, taking the Edge component. SVSS is streaming video security service. That uses a number of protocols, and I'll give you a bit of an introduction here because we refer to them later in the session, to set up a video stream. The protocols are things like RTSP for session setup, STP, as I said, for media stream negotiation, and RTP. The actual exchange to set a media stream up is quite complicated, and this is a fairly reduced description of it. We start off with a describe, request, get a response, set up, get a response, and finally a play. Those three methods are all done in RTSP. And then finally, we get single or bidirectional media stream transferring the data between the client and the server. So I'll hand over now to Alex, who will talk more about our porting experience on CHERI BSD. Just that button to advance.
Hello, everyone. My part covers practical aspects of porting, benchmarking, and fixing real issues. We started our work with QEMU emulation. It allows us to fix most issues before we get actual hardware. Next step was finishing our work polishing on actual hardware. It's interesting that we spent 2 months mostly on packaging and delivering dependencies, not fixing our C code. We used cross-compilation both on macOS and Ubuntu hosts to get binaries for CHERI BSD and QEMU targets. Classical C build pipeline used Mason for building dependencies and make to prepare our Edge binary. We also enabled all possible CHERI warnings to get all possible issues before running on hardware. What we needed to package our software, we ported 7 dependencies not available in pure CARP API. So we cross-compiled glib and other dependencies is what's important. We also cross-compiled OpenSSL 3.5 to enable PQC support on our platform. As I mentioned before, we actually fixed our C code issues. It took 2 days, less than 5% of whole work. It's impressive results. We can repeat it for next products because most complex work was packaging and tooling. What we discovered during our exercise, we fixed 3 subtle issues in our code hidden for years, but discovered while running on actual hardware, and fixed a couple of issues in independent libraries. I think it's quite impressive result because we applied code hygiene before using all possible code sanitizers available for default tools on Linux. To test, to benchmark everything, we run 4 streams. First one is direct link to a TSP camera streaming in ultra-wide HD quality at 30 frames per second. And next box is reference OpenWRT router, is an an ARM processor. Next one is Morello board, and another one, bottom, is QEMU. Just for reference, we can't compare them one by one because it uses emulation. What we got? We got pretty good results showing that there is no large delay added by Morello board. It compares with other streams. QEMU has some spikes due to low-end machine and emulation mode, not that powerful one. And show that this slide shows that we got pretty good results both on jitter and delay, showing that actual hardware Morello board works pretty good. And while on the right shows that QEMU adds some delays due to emulation. The same we can say about jitter, almost all curves overlaid. So pretty good results. So security comes with low cost. That's a good result. Thank you.
Okay, to finish off, did we meet our goals? Well, absolutely. I personally was a bit concerned about the potential performance impact of moving to any Cherry board. I was wrong. As Alex has shown you, the performance really was very good, and certainly the critical elements, delay and jitter, were well acceptable and very comparable with a widely used router. We did identify some problems, a few problems, a small number of problems with our own code. And the good news is that fixing those problems obviously extends the benefit to our current release products running on standard ARM and Intel architecture processors. We identified some third-party problems with third-party packages. We can make those changes we made to those packages available to anyone that needs them. Is Morello suitable for deployment? Yes, definitely. Certainly, if we have elevated security requirements and we need really the best possible security and ongoing validation of communication, we do. However, it's subject to cost and form factor. You see from outside, we have the large Morello CHERI case. We like to run Edge on a drone. If we run that, we're going to need a very big drone. So we'd like to see in production a much smaller form factor. Future work, well, we'll continue to test. We want to get other components, particularly our core software running on Morello CHERI, and further ports for other parts of our product for code validation. So to finish off, we have a demo outside, a very, very simple-minded demo. We are running a camera through Unicus Edge on Morello CHERI through a 5G router, which unfortunately is not working too well here because we have a pretty rubbish 5G signal, but it doesn't matter. You can actually see the system running. So thanks for listening. If any questions, I'll be happy to answer them.
So great. First, a comment. It's great to see that even without using a CHERI system, you would detect bugs, and that's really impressive. And well, a number of people have found that in existing code. So CHERI is a good way to help increase the quality. Any question in the room? Yes. Oh.
Wow.
Good throw. Yeah, I was just a bit curious on the jitter graph that you showed earlier. The Morello Edge one seemed to have kind of like two bells. Can you explain why it had the two, like the dip in the middle, if that makes sense? Like here, the blue one is kind of like a nice bell curve, while the BSD Morello Edge one isn't.
Do you know why that is, Alex?
Actually, I do not have an answer because we have not time to investigate it deeply, because we got result we wanted. It works like actual hardware it doesn't matter for us what the deep nature of that belt. Okay.
Okay, thank you.
Thanks. I should say we had the Morello CHERI just about a month to 6 weeks ago, so time has been quite short. Oh, nearly got me.
Hi, Peter. Fantastic case study. So besides presenting it here at Cherry Blossoms, will you be documenting it, writing it up, posting it somewhere for other people to refer to as an
We
example?
will be documenting it. We hadn't thought about hosting it for other people to test. We can certainly do that. Maybe we can.
I just mean hosting it as a resource that people can look to as a case study to say, this is what is possible on Morello and with Cherry and not incur performance bugs.
Absolutely, we will be doing that. We were discussing it yesterday. We will write some kind of technical note on our experience and get that published fairly soon.
And in fact, that's also something the Cherry Lines like to help with. We like to publish things from our members, so blogs or documents or anything. And well, we are in the process of creating a library of content from our members. So this would be welcome in the library.
Available.
Yeah. Any more questions? No? So thank you again.